Hello, welcome back to the channel. So let's do a mixed question now. This question is based on two concepts. The first concept is converting this limit notation into a definite integral and then calculating the definite integral using substitution. So we have already covered both of these concepts in detail in our previous videos. So if you don't know how to convert this limit notation into a definite integral, I would highly suggest you to first watch that video in order to get the full context of this video, and you can always find that video on the I button above. So first of all, before solving this question, again we have to know some concepts related to Riemann sums. So our delta x expression is always, as we know, b minus a over n. Our xi expression is a plus I delta x if we are taking the right Riemann sum. So in this case, since every notation is according to j, so we'll take xj instead of xi. So if we take everything with respect to j, our xj would become a plus j delta x. And now let's write this equation and identify our delta x and xi's in this case. So if we write the notation again, this is limit n goes to infinity, sigma I goes from 1, j goes from 1 to n. J over n can be written as, j over n square can be written as 1 by n times j by n. Because in these type of questions, we always look for a j by n or I by n term. So we'll break this j by n square part into I by n times j by n. Again, if you want to know more about why we did that step, I would highly suggest you to watch the previous videos, which were based on converting this limit notation into a definite integral. So we'll break j by n square by using that approach into 1 by n times j by n, and the square root can be written as 1 plus j over n whole square. And now if we identify our delta x, we know that our delta x is always a term which has n in the denominator. So by comparison, we can easily see that our delta x in this case is 1 over n, and based on our delta x, our xj would become, since our xj is a plus j delta x, in this case it would become a plus j over n, right? And now we have to find a similar looking term to this one. So we want to find a term which would be similar to a plus j over n. And we can find j over n over here, and we can find j over n over here as well. And if we compare j over n with a plus j over n, we can clearly see in this case that our a is indeed equal to 0. So if our a is equal to 0, our delta x is already 1 over n, and delta x is b minus a over n. So this can be equated to 1 over n. N will cancel out. A is 0 in this case. This is 0. So b minus a would be just b. And by following this, our b would be equal to 1 in this case. So we have our lower endpoint, which is a equals 0. We have our upper endpoint, which is b equals 1. And now in order to convert this sigma notation into a definite integral, we know that this will change to the integral sign with the lower and upper endpoint. Every occurrence of delta x will be changed to dx in this case, so this will be changed to dx. And every occurrence of j by n, since our a is 0, so every occurrence of xj would be changed to simply x. So let's write this equation again, the limit notation again. If we copy this down, now we know that we have to convert this limit notation into the integral sign. So the lower endpoint was a equals 0, the upper endpoint was a equals 1, and 1 by n will be changed to dx because your delta x was 1 by n. Every occurrence of j by n will be changed to, so every occurrence of xj would be changed to simply x, since our xj was j over n. So our j over n would become x, and this would become 1 plus x square, right? So now if we simplify it and write in the correct form, a correct representation, we can write this as, just by rearrangement, we can write this as x times under root 1 plus x square times dx, right? So now this is the definite integral that we have to calculate in order to solve this question. And now you can clearly see in this case that if I assume 1 plus x square to be my u function, the derivative of 1 plus x square is 2x, and I have an x term over here, so I can do some manipulations in order to solve this definite integral by substitution. So let's follow that process. In this case, if we assume our u to be 1 plus x square, our du by dx in this case is just 2x. If we shift the dx to the other side, so du would be 2x dx, right? So now we want x dx, so our x dx is du by 2 and 1 plus x square is u in this case. So let's write the definite integral again. The definite integral is originally integral x times 1 plus x square dx from 0 to 1, right? And now, since we are changing our x to the u notation, we will also have to change our endpoints based on the function transformation. So when our x is equal to 0, which is our lower endpoint, our u is equal to 1 plus 0 square, so u is equal to 1. And when your x is equal to 1, which is your upper endpoint, your u is equal to 1 plus x square, which is 1 square, so u would be equal to 2. So when you'll change all the conversions to the u function, your lower endpoint would become u equals 1, the upper endpoint would be u equals 2 in this case. Now let's make all those transformations. First, let's rearrange this equation in order to visualize our substitution clearly. So I'll write under root 1 plus x square first, and then I'll write x dx in this case. So now when converting everything to the u function notation, our endpoints have changed. So the lower endpoint has now become 1, the upper endpoint is now 2 in this case, right? Lower endpoint is 1, upper endpoint is 2 in this case. We assumed 1 plus x squared to be u, so this would be square root u, x dx would be du by 2 in this case. So now we can take the 1 by 2 out, so we just have to calculate u half du, right? And we can use that formula that whenever we have to calculate u of n du, you can write this integral as u to the power n plus 1 upon n plus 1 plus the constant of integration. So we'll use the same formula. So the answer would be, in this case, half times, so the definite integral would be u 1 half plus 1 upon 1 half plus 1 with the endpoints 1 and 2. So now this becomes 1 by 2 times u to the power 3 by 2 upon 3 by 2, right, with the endpoints 1 and 2. So now, since this 3 by 2 is in the denominator, I can take the 2 in the numerator, right? And the constant can just come out, right, in this case. So it would be 1 by 2 times 1 over 3 by 2 with the endpoints of the function u 3 by 2 with the endpoints 1 and 2 in this case. So if we multiply this, it would be just multiplying 1 by 2 times 2 by 3, and if we substitute that endpoints to calculate the definite integral, it would be 2 to the power 3 by 2 minus 1 to the power 3 by 2. So this can get cancelled out, and the final answer would be 1/3 of 2 to the power 3 by 2 minus 1, because 1 to the power 3 by 2 is simply 1. So this would be your final answer. I know this was a complex problem to solve, but if you know the approach on how to convert a limit notation into a definite integral and then solving the definite integral using substitution, it's only the calculations which are a bit trickier in this case. But if you know the approach on how to solve these type of questions, you can easily solve these questions without facing any problem. So that's it for this video. I hope you found this video helpful. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.